Good morning, everybody, and welcome to the video. In this video, I want to talk about data modeling concepts, right? The one that I have essentially watched on YouTube, and these concepts could be applied to Elasticsearch as well. So, I want to discuss two items here, that is a reference model and embedding model. So, let's talk about that in the video. These all slides have been taken from a YouTube video, right? So I will give you the raw source if you guys are interested, right? So let's talk about it. But by the way, this concept could be applied to Elasticsearch. I do have a video where I presented one to many. We could apply this concept here as well. And here is the actual source where I was learning from. So let's see what the author says, right? So here, basically, there are two main model. There is embedding model and the reference model. In embedding model, what the author says is basically if you have the many part, right, having that on a single document makes more sense. In this scenario, let's say if the data is always accessed together, storing it in the same document is more optimal, right? So again, this is called embedding model, where you define the many part as an array of objects, right? So the author also discusses the advantages and disadvantages here. So retrieve all the relevant information in a single query is an advantage, right? I could grab all the nutrition for a given product, right? It's good because I'm avoiding using joins here, right? Then there are some of the limitation by using embedding model. What if your many part has a lot of items? For example, the author shows a very good examples, right? A large document size could be a problem. Performance can degrade when using arrays with large number of elements. So what do we do then, right? So those scenarios we could opt for a reference model. Here the author shows a classy example where this embedding model caused a problem, right? A product can have several reviews, right? Can have many reviews, right? So by using this, what if there are 1,000 or 1 million reviews? Well, as you see, that's a problem, right? So those scenarios are where you might opt in for a reference model. So here in this model, hopefully you guys can see. So what the author says is basically it's the same example, right? Product with several nutrition. So break it into a separate collection if your document size is gonna grow, right? If the many part grows, break it. So what we do here in this exercise in the reference model is the many part that you have, you will always put the reference. So here I'm putting the reference in the many parts. If you observe product ID here, right? And then I have a product collection, right? So it's a pretty good way to essentially break your documents into collections. Again, this is when you do expect that there are this document size grows a lot, right? A great way that the author showed. Now, there are some of the advantages and disadvantages that comes using this technique. For example, you will have a smaller document size, which is good. Infrequently access information not needed on every query. Reduce the amount of data duplication. The limitation is more queries you need to retrieve the data. A potentially larger collection sizes, more overhead cost by increased number of indexes, right? You might have a lot of indexes, right? That could be a problem, but updating that particular information is much more easier, right? For example, if I want to update, let's say nutrition, it's easy. I can just go to the collection and update. So there are pros and cons both with this model, right? How to choose? The author says it's very easy. If you need all the data, prefer the embed model. And if a portion of a data is rarely accessed or frequently updated and growing, move it into a separate collection. Now, again, the author shows your one-to-one relation, right? A simple key value, right? You would model it. Now you have one to few. For example, a user might have few address. I know that this array won't grow. Here I can opt in for an embed model, right? But here is a scenario where you have one to many. For example, a single computer can have several parts. The author says here, okay, for a computer part, it's fine. This wouldn't grow that much. What if it was an aeroplane, right? For an aeroplane, you might have a millions of parts, right? So maybe using a referencing model makes more sense here, right? So here, as you can see, what the author shows is product, and product has several parts, and then basically the parts are broken down into a separate collection. So now when a user clicks on a product, you can show or you can paginate across the products, right? So a very good way to model that, right? There is a scenario where you might have 1 to a million, right? In those scenarios, author says, for example, IP address and logs, right? A single IP might have millions of logs, right? So the author says is to have the ID in the many parts, if you observe here, right? So it becomes much more easier, right? And I guess the last slide that I took from here was many to many. So here we have an author and a book collection. Author can have several books. A single book can have multiple authors, right? So a two-way embedding model can be used here. For example, the author did mention to have the reference of books in the author collection and have the author in the books collection, right? So yeah, this is the reference of the video. I'll leave that in the description if you want to check that out. It's a 35-minute video. I do encourage you guys to check the video out if you guys are curious to learn further about that, right? And again, these same concepts are applied or can be applied to Elasticsearch. I'll leave my one-to-many video along with the snippet how we essentially did this in Elasticsearch. So with that being said, that's all I have for this video. I do not have anything else. And if you have any more questions, list your question in the comments and we'll try our best to answer those questions. Thank you so much and see you guys next time.